we've been looking at bivariate data where we had two variables, and at the moment, lately we've had either it been a categorical and a numerical with the two, or we had two categoricals. Now we're going to be concentrating a lot where they're both numerical data variables. So when we have a numerical, we do often graph these in a scatter plot. So it now becomes crucial, so it's like a x and y axis. It becomes crucial that you determine which one is the response variable, because that must go on the y-axis, and which one's the explanatory variable, because that must go on the x-axis. So you must determine that at the start. If it could possibly be either way, they will then tell you what which one's going to be which. All right. So say for an example, I could pick. Say I did all your two variables. So I took all your height. I took down your height and your weights in this class. Okay. So height is going to be the explanatory, because you can't change. The height is independent. It's going to be what it's going to be. But weight will change, could change. And so weight would be along here. So what you'll see is, we'll get all these dots. So the dot would indicate, that would be an individual, where we would say their height is, say, 1.7 metres and their weight was, 80 kilos or something like that, right? So all those dots are the individual people, and you've gotten two pieces of information from it, the two numerical variables. So with the scatter plot, you end up with these dots, and what that is we then start to look at this and we comment on the scatter plot. So we will look into this further as we go into it, but just today, just to do a brief overlay, when we look at these scatter plots, we'll look at these three things. And the first thing is the form. So the form is like which way the trend's going. So this one is sort of following a straight line pattern. So this one we would say is linear. If we only really say either it's linear or non-linear. So if it has a sort of a different type of pattern, so it could look like the dots did this. So you can see that it did something like that. There is a pattern there, but it's not, we call it non-linear. I mean, it's not a straight line, and that's pretty much all we need to know about that. We like to deal a lot with linear stuff in further, and if it's not linear, we'll show you ways to make it linear. Okay, so that's what you do. You either say whether it was linear or non-linear. We'll then look at the direction. So say this one, it's going up. So if a line's going up, it has a positive gradient. So this one is in a positive direction. So if you had another one and say the scatter plot looked like this, so you can see it's going downward, that would be a negative direction. Okay, so you'd have to comment on that. And then we'll look at the strength. So just to briefly go over the strength, we'll go over a bit further next week. But see, if your dots are really close together, it's like it's forming a really strong relationship. So we would say that's strong because they're so close to joining up. That's a strong. If you have it that the dots were like really weak and sort of further apart, like that, there's no sort of line that best fit. It's all getting a bit wonky. So that one would be like really weak. Okay, we'll look more into that next week. What we are going to do is I'm going to look at how you do a scatter plot on the calculator. So you don't have to draw a whole scatter plot ever in the exam, and we're not going to make you do a whole one. I'm pretty sure you don't have to do a whole one in a SAC. Generally, it is just add a few extra dots that might be missing. But we do need all the calculator stuff. So on the calculator, so I've grabbed this question. So if you look here, the table above shows maximum and minimum temperatures during a hot week in Melbourne. Using the calculator, construct a scatter plot with minimum temperature as the EV. As I said, this one, there's no way of telling which one could be the EV or RV. So because you could put it the other way. So they're telling you. So I said when it's a bit iffy or you don't know, they'll tell you, and they've told me. So what a good idea in an exam or that is when you get told that something's going to be, just put an EV next to it and an RV, and also put an X and Y. They've already done it there, just so you remember. Okay, so that when we draw a scatter plot, when we do it on the calculator, we're going to put the max on this side and we're going to put the minimum on that side. All right, so I'm going to stop this. Okay, so we're going to look at how to interpret a scatter plot. So first we're going to talk about your first comment on the form. So whether it's either linear or non-linear. Okay, so the linear just means a straight line. So if in general we're seeing like the scatter or the dots roughly following a straight line, we call that linear. Okay, we said if we have some with what we'll see is you might see a pattern. Sometimes we have to be really careful because sometimes it looks like that, so it'll be a bit of a curve. They can be a bit tricky. We'll look at them anyway, and we'll look at straightening them up. But anyway, so we either say they're linear or non-linear. Most of yours are going to be linear. The direction, we say whether it's positive or negative. So obviously if it goes up, this one would be a positive, and if it has a downward, it's negative. And then the next thing we're going to look at is the strength. So the strength is here, as you can see, it says the strength of it is an indication of how closely the points in the scatter plot fit a straight line. So if you look here, if you have them in a perfect straight line, then that is a perfect linear relationship. So that is super strong, or we often call it perfect. Okay, so if you look down here, down in this one, they're not all exactly in a straight line, but they're very close together, so that's a strong relationship. When you have them over, say, this one down here, it's going down, so it's a negative, but they're very far apart, so that would probably be a weak one. They're hardly, forming a line in there. So how do we interpret this in with a more structured way? Is we look at this and we find this value called Pearson's correlation coefficient. So you've got to be really careful of the naming because it's Pearson's correlation coefficient, and that is what we call the R value. So we have these categories here, and the R value, so the R value ranges between -1 and +1. So if you have a -1, that's a perfect negative relationship, yeah? So that would be that straight line going down. If you have a +1, that's a perfect positive relationship. So and that would be like a straight line going up. So then you have all the numbers in between. Obviously, if you have 0, that's no relationship at all. Yeah, it's all random. Now, you've got in your notes a few examples. So if you had to, just without knowing the R value, you could just estimate and have a go at what they are. So you can use them. But we are going to look at finding the R value on our calculators. So we're going to go show you that. So let's go record this. So just to recap what we just did on the calc. So on the calc, to find the R or all the other values, while you're on your lists and spreadsheets, so while you're in there, you'll press menu, stats, stat calculations, menu, stat calculations, and then you'll press lin reg the A plus B X, okay? And then you click OK, make sure your X list, so then the next part, make sure your X list is your EV and your Y list is your RV, and then you'll have everything you need there, and that's all we really go. So to use, now this is really important. So even though it's not very big, can you really asterisk this? Okay. Because what the R value does is it's balancing that line between all the dots. So it's calculating all those distance and it tries to balance it. So what happens when we have an outlier, if we have like one really far away from everything else, but what the calculator does is try to balance that one in there. So it wouldn't be a true representation, because if you have that outlier, it's going to say it's a bit weak. When it, like, all the rest could be perfectly in a line and there was this one odd bod, which could be entered in wrong, you know, when we're doing statistics, or, you know, if it was something over many years, you know, the little odd two bods could have been the COVID years. In years to come, like, there'll be something that all of a sudden something's gone different, yeah? So it's not the general trend. So you can only, so what we're assuming when we use this R value, we're assuming it's following a linear pattern. So we're assuming that it's not curving or anything. We're thinking that, and we can't have any outliers. It's no good. So there it says, use a correlation as a measure of strength. The variables must be numeric, so both numerical, and the relationship must be linear. So, and there are no outliers. Make a little note, say, when using the R value, you're assuming it's linear. Okay? So we might not know for sure, and we will look into that later, but they'll say in an exam question, what assumption are you making using this R value? And you just have to say it's linear. Okay, we're assuming it's linear, or it'll be a little multi-choice. Okay. So the next bit we're going to look at is the coefficient of determination. So this one's the coefficient of determination. You've got to be careful when you're reading what they're asking for, and that's the determination. And as you can see, it's R squared. And it was back on our calculator. You saw R squared was calculated when you were in listen spreadsheets and you did the lin reg, the A plus BX. Yeah, you saw they had all the A, B, blah, 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 blah. They had R and R squared. So you could find it there in the same spot where you found the R value. Okay, so what the R squared value tells us, it's the degree to which one variable can be predicted from another as long as they have a linear relationship, okay? So we've assumed they have, and we're found the R squared. So what they ask you, they'll often ask you calculate the R squared. So the R squared will always be a positive number, because even if the R's negative, remember, a negative times a negative gives a positive. So it will always be a positive number, and it'll be less than 1. Okay? So say, for example, it could be 0.76, whatever, okay? So the R squared value will be less than 1 and a positive. So they ask you to determine it. So say, for example, I've done a little example down here, so I'll go through this. It says the correlation between weight and height, so where they collected the weight and height of all these individuals, and they found the R value to be 0.8. So we're going to say 0.8, that's a strong relationship. Now, if they ask me to find the R squared value, obviously I could just square 0.8, or you could look, if you've already done it on your calculator, it'll be sitting there. So if we square 0.8, we get 0.64. Okay, so what we like to do is they'll ask you to interpret. In further, if you get any words that say interpret, you will know I have given you a fill in the blanks. Okay, you don't have to think up the statement. If they say interpret, I've written a statement for you. And here it is. So if I did this example up here, it says, so interpret this 0.64, I would use this and I would say the coefficient of determination tells us. Now, see the yellow? That means you have to fill it in. And I've just shown you, like here is what you have to do. You have to change the R squared to a percentage. So 0.64 becomes 64%. So I'd say, tells us that 64% of the variation in, now it's not response, we would say here, we would say weight, yeah, is explained by the variation in the explanatory, so we'd say height. So if it's in yellow, you're changing it or writing what your example actually has, and then that's what you exactly write. So what we're saying is, what that says is when we are adjusting people's height, so when we're moving, when we see their heights changing, we are seeing that, we're saying 64% of the changing in people's weight is due to the changing of their height, okay? So there's other factors, isn't there? If it's 64%, we've got like 36% of other things as well, you know, which is true. It could be diet, could be, you know, lifestyle, whatever. It's making a whole difference. But that's all we say. We're just saying when we change up the height, we're seeing that it changes the weight about 64% of it, okay? So if we have that, if it's 64, that's pretty high. We would say that's pretty relating. There is some correlation there. We don't know why, but, you know, we don't care. We're just going to say, yeah, there is changing happening there. So here, that's why down here I've said if it's less than 30%, we would say it's insignificant. Like really, if it's under 30%, who cares? There's obviously something else making things change, and off they go and they'll go study something else, all right? So that's the R squared, and that's what you need to use this interpreting. So let's do this exam question. Okay, so with this question 9, so the coefficient of determination is this. When you read that, just put R squared, because there's the Pearson's correlation coefficient, and then there's coefficient of determination. You don't want to get it wrong. They've said determination, so that's the R squared. Now they want you to go back to the R value. If you have a squared number, say you have 4, and you said it was squared, but you want to go back, you could do the square root, and that takes you back to 2. Is that true? Yeah? So if I know a squared number and I want to go back, I actually have to do the square root. But you need to remember, if you have -2 times -2, that gives +4, doesn't it? And so does 2 times 2, that equals 4. So we have to be really careful here. When we do the square root of this number, 8339, on the calculator, it will just give you the positive answer. That's what it actually should say. It's a plus or minus. So you need to make a big note there. You need to decide whether your R value is R value positive or negative. Yeah, they'll give you information. So the way you do it, see, like I can see the graph here. The graph is negative. So I know it's going downwards, that R value must be negative. Okay, so if we do the square root of that number, all right, so we got this to be, the square root is 0.913, okay, but I know from the graph, this graph is negative, so I'm choosing it to be negative, and which is why I pick A. Okay, there will be other things later on. They could give you, and just so you could write there, if they gave you the equation, so we'll see later on, A plus BX, obviously, if this B value, if that is negative, then R is negative. If that is positive, then R is positive, okay? We'll look at that a bit later, but obviously if you've got the equation of the graph, so down here, here's another little bit they can ask us, just to be careful. So they said the coefficient of determination is 0.875. So what happens if I was to interpret this, I would say 87.5% of the variation. Now I'm going to say in the response variable, so I would say in life expectancy can be explained by the variation in HDI. Okay? So that's me just using that statement. If you go back to the other page, I obviously know it off by heart, so I've done that. So this was in yellow. I had to change that. I had to change the two variable names. Okay? So 87.5% of the change is explained. So therefore we're saying 12.5% is not explained. So that was just a trap that they could do. They could say what's not explained was the less. So if you do 100 minus the 87.5, you get 12.5%. That's why I said it can be explained or not explained is. Okay, so here is another example for the R squared exam. So the average gold price in dollars per ounce is plotted against each year over a period of 1980 to 2000. The least squares line is fitted. So we'll talk about this soon, but that is like our lin reg line, which we'll do soon. So they're telling us it's following a linear relationship. So here's what we're going to see. This is going to be our A, and this is going to be our B. That was Y, and that is X. So you can see that B is negative. So when they asked me, they told me R squared is this, and then they're asking me what is R. So R is going to be either plus or minus the square root of the R squared number. So when you do that, now we have to pick which one it is. We're picking negative because B is negative up here. Okay, so in the end, what is our answer? So if you were doing this in an exam, you could have quickly seen that it's negative. Get rid of those solutions. You've only got 2. And what is it? The square root of that. What is that? Thanks. So it ends up being D. Negative 0.7324.